I'm James Robinson. You're listening to Multiverses. We can think of the philosopher of science as being a step removed from science itself. So science is trying to produce scientific knowledge, and the philosopher of science is trying to elucidate that and to incorporate it more broadly into our philosophical frameworks. The historian of science is also a step removed, but in a different direction. They're trying to understand how it is we got this knowledge in the first place. Who are the individuals, what are the stories, or what are the societies that produced these scientific discoveries, or just the slow drip-drop accumulation of scientific knowledge? Our guest this week is Patricia Fara, a historian of science. She is an Emeritus Fellow of Clare College, Cambridge, and she's written a lot of wonderful books. Science, a 4,000-year history I really enjoyed for its incredible chronological scope and the wonderful way that it's arranged, not chronologically. She's written some biographies of Newton. She's written a lovely book about the rise in female scientists that came about with the First World War, A Lab of One's Own. And we have just a wonderful, wide-ranging conversation that I'm going to fail to summarize here. But we touch on some themes like contingency, how perhaps things could have been different within the history of science had apples not fallen. And we talk about mythologizing and the stories we tell after the fact about scientific discoveries and breakthroughs and the characters involved. And I think the question is sort of there in the background, well, how healthy is this? And I think explicitly at one point, Patricia says, well, for example, we sometimes have this view of a scientific martyr, someone who's given up their life in the pursuit of science. Marie Curie is kind of a paradigmatic example. And that may not be the healthiest symbol or points to dwell on, right? That may not attract extra people to become scientists, and it may not be the best even way of pursuing science. So I think this is just a wonderful conversation. It gives a window into the views of a historian of science, and I think this is just a very valuable perspective. So I hope you enjoy this as much as I did. Hi, Patricia Fara. Welcome to Multiverses.
Well, thank you very much for inviting me to participate, and I'm looking forward to our conversation.
Oh, wonderful. I'm going to start with a very big question. What is science?
What is science? That's something I often ask my students that, and they get very angry with me because science. My standard answer is science is what scientists say it is that they're doing. I don't think it is an abstract entity. I think you can describe yourself as doing science, but it's obviously meant so many different things to so many different people. And now, if we want to go back, I know, to the Babylonians or even to the Middle Ages, we would more recently we would say that people are doing science, but they wouldn't themselves have said that they were doing science at the time. So it's a concept that's constantly changing. Most obviously, it comes from the Latin word, well, in English anyway, it comes from the Latin word scientia, which is knowledge. But science in, say, the 18th century meant something very different from now. Science then meant book learning. So you could have the science of history or the science of languages. It's only relatively recently, more or less during the 19th century, that it became narrowed down to talk about knowledge, to mean knowledge of the natural world. So I think it's a very loose umbrella term, and science is whatever you happen to think it is at the time.
I guess one of the difficulties is there's some justifiable respect for science.
Science has been, that respect has been established. I mean, I think it's related to the question of what is a scientist and what do scientists do. And one thing I do feel quite strongly about is it's completely anachronistic to use the word scientist before it was invented in the 1830s. It wasn't even in widespread use in this country until the early 20th century. And to use the word scientist to describe someone and say, describe someone like Galileo, for example, or Copernicus, is completely misleading, because scientists now, they go to university to study what they're doing. There's a very strongly established career structure. It's professional. It's held in high esteem. Scientists may well be religious people, but their religion does not enter the body of scientific knowledge. Whereas if you go back just a couple of 2 or 3 centuries into the past, what natural philosophers were doing was very different. Someone like Isaac Newton, for example, who's often seen as the forefather of modern physics, was very much a very religious man who thought that the whole point of studying the natural world was to get nearer to God. So I think those sort of considerations of how the pursuit of knowledge, the value of knowledge, the meaning of knowledge, how those have changed over time, has to play into your bigger question of what science is.
Yeah, it's really interesting in your book, Science: A 4,000-Year History. You talk about the different interactions between science and other fields, and both religion and alchemy were all melded together within Newton. Keynes famously called him not the first scientist, but the last great magician.
The last Babylonian, something like the last. That was what John Maynard Keynes said. He was the last Babylonian who looked out on the world with the eyes of a magician, something like that.
Something. Okay. Yes.
Vegas, yeah.
And as you say, well, scientists may still have their own religious opinions now, but they don't influence science as far as we can tell.
Well, they probably do influence the way that people approach the natural world. So I think there's an influence in that sense, but they don't openly articulate their religious beliefs within a scientific context. I think that's the difference.
Right. Yeah, I think that makes sense. So there could be certainly also an influence on the direction of science. I'm wondering if one were to write a history of science 4,000 years from now, if people would look at what we're doing now as science, or maybe they'd see it as some kind of pre-scientific activity where we're getting lucky sometimes, but really it's terribly disorganized and haphazard, and there's still a lot of progress to be made in terms of delivering a process which actually is kind of reliably delivering knowledge.
Well, I don't know about 4,000 years from now, but just looking after considering the last 20 or 30 years, a bit less ambitiously. I mean, one obvious direction which I think science is taking, which I don't think is a good direction, is that thanks to government regulations and thanks to the REF, it's far more directed. So it's becoming far more applications based, and there aren't the opportunities that there used to be for completely free thinking. There aren't the opportunities for experiments to fail. I mean, if you're writing a research proposal, you have essentially to set out what you're going to show. You can't do an experiment in the sense of, well, I'm going to see what happens. And under the current regime, it would have been absolutely impossible, to just take one example, it would have been absolutely impossible for Crick and Watson to absent themselves from their postgraduate studies and look at something completely different and come up with the structure of DNA, because everything's so tightly controlled and oriented and focused now, which I think is a great detriment to free-thinking scientific endeavour.
So perhaps we don't have people working within the religious paradigms as they used to, but they're working within a structure that's created by political forces, which maybe also constrains science in a sense.
There's also a great pressure to publish, and no one seems to have worked out in advance that the fact that in order to get promotion, you have to publish so many papers and so many books, and also the rules of open access are absolute godsend to the publishers. I mean, who can charge what they like. I mean, that's another phenomenon of modern science, which I think is a great failing.
I wonder also if people will look at the representation of people within science and say, well, clearly something was wrong in the 20th century, just as in the 17th and century, it was just gentlemen who were doing science and people who are kind of independently wealthy or rich enough to do so. They might look at today and say, well, there's just a thin slice of society represented here. So how could that be, how could that generate the kind of outcomes or foster a really diverse set of research as one would want?
Well, there is far more access to education for everybody, whatever their background and whatever their gender, than there used to be. Certainly, there's far wider access than there was in the 17th century. I mean, there's far wider access than there was 20 years ago.
If there'd been more participation of women in science, would we genuinely expect some kind of different sets of results, or perhaps different focus of the fields that were prioritized? Or might we have seen more or less the same kind of progression, I suppose?
I think in terms of knowledge, this what if question is pretty impossible. In terms of knowledge, it might have been similar. Certainly in terms of the way the working place was structured, I think it might have been very different. I mean, one of the great criticisms that women in academia have is the difficulty of being a member of a family, of being a parent, and how much that affects their academic careers. So rather than thinking about the content of scientific knowledge that's generated, I think in terms of how scientific careers and how scientific work is structured, how it operates, I think that might have been very different if women had been in charge. For instance, there might be free childcare, or there might be far greater involvement of men in bringing up their own children, which is certainly a direction in which families seem to be moving at the moment, which I think is wonderful both for the fathers and for the children, as well as for the mothers.
Yeah, but I suppose, as you say, I think perhaps the differences are overstated in terms of what, I think Christine Lagarde was driving at. There's a different attitude of risk, and that was her point, between women and men. And I think that's maybe overstated. And so perhaps you have pointed out other ways, though, in which the history of sciences seems very contingent on particular choices, discoveries, perhaps, and external forces. What other ways do you think things could have developed? I mean, there's an example you give at the beginning of a 4,000 year history is simply to do with units and how it's quite not arbitrary, but the fact that we have 60 seconds in an hour and 360 degrees in a circle all traces back to the Babylonians, and you suggest, in fact, that it's really to do with the ease with which you can write in figures in clay tablets, which is, I think, just a really, really interesting insight that I wasn't aware of. But on the other hand, that seems, that's quite a, for one of a better word, it's kind of a thin difference in a sense. It's a difference of the way that we express. I don't know. It's a difference in the number system, but it's not a fundamental difference in the sorts of knowledge that we have, I suppose. I wonder if can we even envisage a history in which science had developed very differently, and we had a completely different set of discoveries now, or perhaps we had a similar set, but they had arrived in a very different order.
Well, I suppose you can look at how science and technology develop differently in different countries. I mean, that's one way of thinking about it. So, for example, in the 17th century, the country that was most advanced technologically was China. And then, for various reasons to do with the way the academic system was structured, the sort of classic example is that it's a bit like the Middle East, that there was a great sort of lull in innovation in China, and then Western Europe rose to power. But of course, all those things are a very Eurocentric way of thinking about history. I think one of the most exciting developments in history at the moment is that new versions of the past are being written, which don't all originate from the perspective of Northwest Europe, with later on adding in the Americas, and that I think more global histories are being written, and I think that's a far more fruitful way of thinking about it.
Coming back to the role of women in science in this kind of rewriting of history, do you think there are opportunities to understand better how perhaps the history of science that is presented so often is one of some a trail of, I don't know, great white men who have made groundbreaking discoveries? Are there instances where perhaps some more overlooked figures should be highlighted?
Well, I think a lot of work has been done during the last 20 or 30 years, mainly, but not entirely, by women, looking at women who've been overlooked. I mean, the women who were working with their husbands, brothers, fathers, doing a lot of the work, who remain completely unacknowledged. So I think in that sense, we have a very different perspective. It also depends partly on your first question. I mean, what counts as science? If you bring in things like, I don't know, cooking techniques and agriculture, then it's clear that women play a far greater role. I think there's also the tendency, there's a sort of truism that when you write biographies of men, people tend to write biographies of their achievements, whereas when you write biographies of women, you tend to write about their feelings and their emotions. So if you think of someone like Marie Sklodowska-Curie, who is the one woman in science that everybody has heard of, and when I was at university, she was the only female role model that I had, and she was presented in a sort of very, if you like, masculine sort of way. She was always presented to me as a martyr to science, someone who sacrificed her womanhood, who never had any clothes, who never had anything to eat. She was starving, she was in a garret, she was working in the most appalling conditions. She sacrificed her whole life to science. And I think, fortunately, that's a model of success which is now being overcome. And actually, if you look at Marie Curie's life in greater detail, it's quite clear. It's quite clear that she did suffer. But on the other hand, that's a very negative role model to present to budding scientists. I mean, it always seemed to me when I was at university and I was presented with this sort of photo of a miserable woman who was slaving away, there was absolutely no incentive whatsoever to want to go into science. So if we're going to encourage more women into science, I think we have to present more realistic role models, which are more attractive ones. And the same goes for men as well. I mean, there's no reason why being a scientist should it involve a huge amount of hardship and sacrifice.
Do you think let's take the Nobel Prize, for instance. Do you think it's the right way of celebrating achievement in science, as it seems to kind of, again, propagate this idea of individuals and superhuman effort and so forth? Well,
that was what happened when I mean, there's a sort of unrealistic competition, and obviously, I mean, it's quite well known. It's perhaps now, but certainly in the past, it was not a prize that was always given on the basis of merit. There were a lot of other reasons why particular people were chosen. I'll have to think a bit more about that. I don't know what I was going to say. I was going to go back to when Jim Watson wrote his book, The Double Helix, which was an absolute bestseller. And one of the reasons why other scientists absolutely hated it was because in it, well, they hated his representation of Rosalind Franklin, but what they also hated was the way that he presented science as a cutthroat race. And the other people who he'd written about, like Linus Pauling and people like that, who he presented as being in the race, said, we weren't in a race. That's not how we thought about it at all. So he notoriously, 3 men got the Nobel Prize and Rosalind Franklin was excluded, but that very sort of competitive, cutthroat way of scientific research is not particularly productive, and it's a way that it's represented in the literature rather than how it actually is.
Yeah, and Rosalind Franklin, to remind people, took perhaps the key X-ray image of the double helix, isn't it?
Yeah, her PhD her PhD student Ray Gosling took the crucial photo, and then of course there's this huge controversy that's been going on for decades about whether or not she should have won the Nobel Prize. It seems to me that what became very apparent a few years ago is that rather than presenting her as the female victim of male rapacity, which is, it's such a conventional trope to present a woman as a helpless victim, and that's how she's always portrayed. It would be a much more positive role model to present her as a pioneer in virology. She was only working on DNA for a couple of years. She hated it. She left of her own accord because she couldn't stand the working atmosphere. And she went to work at Birkbeck for Bernal. And she started investigating viruses. And she was the first person to find the molecular structure of a virus, the tobacco mosaic virus, which is one of the key viruses. And she went on from then and analysed the structure of several others. And when she died, she was working on the structure of the polio virus, which was later deciphered by her colleague, by her assistant, Aaron Flug. So, especially since we've had COVID, it seems to me every reason why we should be celebrating her as the founder of virology rather than representing her in such a conventional, hackneyed way as a helpless victim, which I think sort of downplays her own agency in a very detrimental way.
Do you have other examples of people that you'd like to highlight, unsung heroes, or perhaps people who have been just misrepresented, or a side of their story has not been
well,
seen?
There's lots of people who are completely forgotten. So someone I'm very interested in at the moment is Hertha Ayrton, who you've probably never heard of, who was about 13 years older than Marie Curie. And I've been reading about her, reading about Marie Curie, and it seems they were very close friends. And Marie Curie, of course, is absolutely world famous because she happened to be making her discoveries in a field that was very important. Hertha Ayrton also made substantial discoveries, but they're about things that seem less exciting, like making streetlights work and working out the patterns of ripples in sand. But when you look at the lives they experience, they're constantly intertwined because they were two women of that period, the early 20th century. They were two women who both married to scientists, both had their own work passed off as being their husband's work, were both excluded from all the official societies like the Royal Society, or it's in England, or its equivalent in France. And both of them were completely marginalised in ways that wouldn't happen now. And Hertha Ayrton is someone that we've never ever heard of, but she was the first woman who was allowed to give her own paper at the Royal Society. So before that, a woman had written a paper for the Philosophical Transactions, Mary Somerville, in the middle of the 19th century, but she wasn't allowed into the actual building of the Royal Society. Her husband, who was a doctor, had to go in there and read her paper for her.
Okay.
But Hertha Ayrton was allowed to read her own paper. She was nominated by several fellows to be a fellow of the Royal Society, but she was turned down on the excellent grounds that she was married. That was the official reason why she wasn't allowed to become a fellow of the Royal Society, was because she was married to another scientist. So she was constantly marginalised and sidelined. And when you look at Marie Curie's life, although she obviously became far more famous than Hertha Ayrton, she also was constantly marginalised. There were problems. She couldn't file patents under her own name. She couldn't become a member of the French Academy. She was absolutely vilified in the press as being a foreigner, an intruder, an invader. And so the two women actually experienced very, very similar difficulties, even though one of them was world famous and the other one we hadn't heard of. And they were very close friends. There were very few people like them, and they bonded together and saw each other very frequently. And Marie Curie came to stay in England for about 3 months with Hertha Ayrton. She went through a stage where she'd had a complete physical and psychological breakdown. So Hertha Ayrton looked after her, and the two women and their daughters, between them, they had 3 daughters. They spent the summer together.
Do you think it's as important to understand science not as a series of theoretical breakthroughs, but in terms of all of the groundwork which enabled those? So in this case, it would be cumulative social breakthroughs that allowed women to participate more in science. But in other cases, we might think about the technological breakthroughs that developed optics for telescopes and so forth. How do you think about the very visible achievements of particular individuals versus all of the much smaller things going on all the time which paved the way?
Well, they paved the way, but there isn't a predefined direction. They could have, the same discoveries could have led to a very different outcome. And there's all the stories about key discoveries that were made that were completely ignored. So the classic example, I can't remember his name, is someone who discovered that in order to reduce the incidence of puerperal fever in a maternity ward, it made a colossal difference if before the surgeons went in from the operating theatre into the maternity ward, if they washed their hands in antiseptic, then the mortality rate of the women giving birth just absolutely plummeted. He reported that and wrote a paper about it. But for 30 years, nobody did anything. I mean, they refused. The surgeons just went on entering the ward as usual, and thousands of women died because they didn't take any notice. So it's not really enough to make the discovery. The discovery has to be accepted and broadcast and implemented. So the science in the laboratory on its own is by no means enough.
Yeah. So that there also needs to be, I guess, marketing that follows through on these
marketing. Yes, I mean, or being in the right place at the right time. There's someone who has to take advantage of the discovery. I mean, there's another example is when lasers were first discovered. Mm-hmm. For years, people said, "Oh, that's a really interesting theoretical discovery, but they're absolutely no use whatsoever." And it was quite a long time before practical applications were found for lasers, like CDs and surgery and all the other things that lasers are used for nowadays.
I really like the example of Aristotle, or Archimedes, and the steam sphere. Is that right?
The little round sphere, that hero's sphere, yes. that was propelled by steam.
Yes.
Is that the one you mean? So there was a sort of little device which, as far as I know, which was intended as a sort of diversion, as a toy, as an amusement, a small model, and there was a little sphere with steam inside, and the jets of steam came out and propelled it round and round and round. So then, in a way, you could say that he was the originator of the Industrial Revolution, but of course he wasn't. I mean, hundreds and hundreds of years went by before all the other factors were in place for industrialization. So one reason why industrialization happened in Britain before the rest of the continent is that we have the iron and the coal and the wood and everything else that you need, and also we have the right people. It's often the Industrial Revolution here is often attributed to the Lunar Society, the group of Northern Midlands factory owners, industrialists, doctors who met every month to discuss ideas. So a whole range of factors had to come into place for industrialization to happen. And to say that it was all invented by the Greeks with Hero's sphere is really not right at all.
Yeah, yeah. Just another example, I guess, of the kind of contingency within science. I mean, the Lunar Society met on days of the full moon because it was like safer to walk around then and to meet
so
up.
They could see their way back. I think they also had a sense of humour. I mean, they called themselves the lunatics. They were aware that having their meetings on the Monday of the full moon was also opening themselves to criticism, to mockery.
I think it's also a good example of the relationship between, I guess, industry, technology, and science. And I think one of the most striking ones, perhaps, is thermodynamics, and how we often think of technology as spinning off from science. But I think historically there's probably been more flow in the other direction, where we've had quite some developed technology, in this instance, steam engines, and people wanted to understand how to make them more capable, more efficient.
Steam engines were invented in the Cornish tin mines in the 17th century, and it wasn't until the early 19th century that all the formulae of thermodynamics developed. Another very good example of that is the Leyden jar, sort of what we would call an electrical capacitor, which was discovered sort of more or less accidentally, that you could have a glass jar with water in, and it could be used to store an electric charge. And according to the ideas, the theories about electricity at the time, it was absolutely impossible for it to work. It was only after the Leyden jar was invented that Benjamin Franklin invented a new theory to explain how it worked. So it's another very, very clear example, like the steam pump, about how the practical application preceded the theoretical development. So yes, I totally agree. I think it often does work the other way around. You don't have scientists sitting in the laboratory thinking, "Oh, I'm going to invent something useful." You get an application, then people think about how they could explain that it works.
I mean, I think there's many cases where, and so another really surprising case I thought was that you mentioned was geometry, and how it came from, it can be traced back to the Babylonians again, who are measuring fields, and that's, if you think about the etymology of that word, it really is. You can see that it does boil down to people trying to figure out how much tax you owe depending on the size of your
I mean, the Babylonians weren't particularly interested in how the cosmos works. I mean, they wanted to look at the stars to make predictions, to find out when was a good time to crown the king or the ruler. And yes, indeed, they wanted to work out crop yields and things like that. And it was the Greeks who introduced the idea of using that mathematics to carry out astronomy.
I'm wondering, though, if this kind of if now and in future we'll see less of these, of technology really needing to be understood by science. I think obviously the role of technology will continue, perhaps becoming even stronger in other ways in science, in terms of us having very large technological projects to find ever smaller, exotic kinds of particle. What I mean is, we don't seem to have places where we have some machine or something that we've invented and we don't really know how it works. To the contrary, we've built, I don't know, computers and semiconductors and solar panels and so forth, came out of quantum mechanics, and it's hard to imagine that happening the other way around, and somehow stumbling upon semiconductor junctions and then figuring out how they work. But so I wonder if we've just reached a level of abstraction with science where we'll find fewer cases like the steam engine, or maybe I'm just not being imaginative enough.
I think that's possible. On the other hand, it seems to me that sort of round about the end of the 19th century, people were also thinking that they'd sort of discovered everything, and then radioactivity came along. And I mean, it seems to me, although I'm absolutely not a high-flying theoretical physicist, but there is all this discussion of dark matter making up a substantial proportion of the universe, and you can't see it, and you can't feel it, and you can't touch it, and all the rest of it. And it seems to me, on a very, very obvious level, that that's exactly parallel to the end of the 19th century, when supposedly there was this ether introduced by Isaac Newton, this ether of invisible particles that are constantly swirling around that transmit gravity rather like sound is transmitted through air. And people absolutely believed in the reality of the ether until Einstein came along and introduced special relativity in 1905. And that eliminated the need for an ether. And I know that there's a great sort of divide still in theoretical physics between relativity and everything on a large scale, and quantum mechanics, everything happening on a small scale. And then there's this dark matter. And it always seems to me, at a very superficial sort of level, it seems a very parallel situation to the one that prevailed at the end of the 19th century. And perhaps we're going to have some massive eruption of what Thomas Kuhn would call a revolution in theoretical physics, and we'll head off in a different direction. That seems to me a very real possibility. And if that were to happen, presumably all sorts of new inventions that we as yet can't conceive of might emerge from that.
Yeah. Well, I think lots of people are hoping for exactly that exciting scenario. but I wonder if it, and I think it does. Again, it reminds me of your point that we can't be too applied in our in the direction that we set for science. We need to create space for pure research.
Yes, free floating research. You have to have experiments with the possibility of proving a negative or finding that that's a cul-de-sac, that is not a fruitful avenue to explore. But you need to be able to do that in order to experiment.
Yeah, I wanted to ask as well about how you view the roles of, or perhaps better put, the goals of the historian of science and the goals of the philosopher of science, if I can say that. Do you see a lot of continuity there, or are there kind of distinct objectives to what people are doing?
I think there's massive continuity between philosophy, history, and science itself as it is being practiced. I mean, there's also related fields like anthropology and sociology. And I think as I'm a historian of science, I think one of the wonderful things about it is in a sense, it's the history of everything. I mean, I write quite a lot about the history of art, for example, and we get students in the history of science department who come from every single faculty in the university. So no, I think drawing hard, rigid lines around the edge of a subject is a great mistake. And if you want to find new ways of thinking about what's happened in the past or what's happening in the present, I think as many analytical tools as you can bring to bear on it can only be beneficial. I don't think we need these hard lines between different disciplines.
Yeah, and I mean, it's interesting. I think many philosophers of physics, at least, are bordering on doing physics work in a sense. That they're actually grappling with most thorny problems, and in a sense that the philosophy of, or the history of science offers something similar, perhaps a step further back, but in that, in looking at the past directions and that have been pursued, we can perceive that, for instance, this point that there needs to be space for free-flowing or free-floating research. That's very clear when one looks back at the history of scientific successes, that often they've just kind of come from nowhere and from people who didn't have a very strong agenda, or perhaps their agenda certainly was peculiar to their own ideals, let's say. So I think, are there other kind of, I don't know, what other advice would you give if you could set the direction or wave a magic wand and change something about the way that science is practiced, or the or even the problems that it focuses on.
The way that science is practiced, not history of science, not history of science.
No, yeah, I guess drawing from the history of science, what recommendations would you make for that very loose thing, science?
Well, obviously, well, not obviously, but I think not to remain too tightly focused within one particular discipline. So as knowledge is getting, people are becoming more and more experts, so it's becoming more and more difficult for scientists in different fields to communicate with each other because they all have such specialized knowledge of a very narrow topic. And I think some of the most exciting breakthroughs happen from interdisciplinary science, when people can borrow insights from other fields. And this is true of history of science as well, that when you borrow insights from other fields and you can set off in a completely different direction, rather than assuming that by heading off in a more and more concentrated way in a particular direction. Obviously, you're going to find out more about a narrow field of knowledge, but I think there's colossal scope. Again, Crick and Watson are a good example. I mean, they read Schrödinger's What is Life of 1948, which had insights from mathematics and physics and biology, and sort of thought about the whole field of biology in a completely different way. And a new discipline was invented of biochemistry, which hadn't existed in the past.
Yeah, I think it's a really good example. Incidentally, I was just reading last night, not What is Life, but I don't know if you've come across it, but Benjamin Labatut's When We Cease to Understand the World, which has it's kind of series of essays / mini biographies. And gosh, Schrödinger was a very interesting character.
Extremely, yes. Yeah, I mean, because he tried to apply the rules of physics to the living world, yes.
Yes.
Yeah.
And I think, I mean, What is Life is just such a striking small book where he does kind of, he almost guesses at the structure of DNA, saying, well, it's got to be something that's almost like a crystal, but it's, well, a kind of aperiodic crystal, I think he describes it, something that's crystal enough that it's pretty solid and fairly regular and robust, but it's got to carry some information, and so it's got to be a little bit, I don't know, more complex than that. So yeah, it's really fascinating. I mean, another interesting thing about Schrödinger is I do think sometimes we get fixated on a particular model of sort of scientific genius, perhaps. Schrödinger was a very, very clever guy, and but he sort of broke away from the mold in one sense, in which that he wasn't a particularly successful physicist for quite a long time, and he only quite late, and at least the way that Benjamin Labatut tells it, very fortuitously came up with the Schrödinger equation, for which is best known, I'm sure. And again, at least in Benjamin Labatut's telling, and you may know or you may disagree, but well, Schrödinger and his wife had a very they both had a lot of different romantic interests, and one of her romantic interests was a Dutch physicist at the same faculty as Schrödinger at the time. And Schrödinger was presenting de Broglie's kind of ideas on how not only photons but electrons and all matter were waves and particles, and both. And he had some incisive and I think in Schrödinger's mind, almost rude questions from this Dutch guy. The Dutch can be very blunt. I mean, that's famous.
That's a generalization, yeah.
It's a big generalization. I don't want to say the Dutch are very blunt, but certainly, so yes, that's an unfair generalization, let's say. But anyway, he got these questions, and one of them was, well, you can't, how can you talk about all this without an equation, right? Which says how these things move around. So, and then Schrödinger went to an asylum for his, or not an asylum, a sanatorium for his bout of tuberculosis, and I think it all kind of came together. Maybe it would have come together had all these things not happened. Impossible to know, but I think very interesting as a story and an example of yes, the apparent contingencies in how we get our how progress comes about.
Yeah, but I think also it's quite interesting the way that we people love constructing stories about discoveries and creating myths. So some of the famous ones, well, one of the most famous ones obviously is Archimedes jumping out of the bath, or Newton and the apple, and James Watt and the boiling kettle, or Kekule looking into the fire and seeing a snake curling around. I mean, all these sort of mythological stories surround the notion of genius, which is how you introduced it. It seems to me that concept of genius is a very problematic one, because for one thing, it suggests that a genius is rather like a saint, that a genius is someone almost invariably a male, who's fundamentally, intrinsically different from other human beings, not just somebody who's very clever, but someone who's in a different sort of angelic sort of realm. And I think that's a sort of mythical version of humanity that's very appealing to us, and that in general, we just keep recycling the same mythical stories in different ways. So this story that you just told about Schrödinger and his wife and De Broglie and all the rest of them, it is a story, and we like to tell stories. Human beings like to tell stories about origins. I think there's often completely different sort of stories that you can tell.
Yeah, I wonder, you've pointed out that the word genius has been used differently throughout time, and it's become something, a property of a person now.
Yes.
But in the past, if I'm right, it was more, a particular characteristic.
Little genius that sat on your shoulder, and it was a gift that was given to you by God at birth.
Mm-hmm. And it was more directed as well, is that right? So Newton was said to have a mathematical genius rather than to be a genius. And
yes, whereas now it's an absolute term. Yes.
Yeah, and as you say, it's similar to canonization in that it's applied to the full person, and it has that kind of mystical glow to it. I do worry about it, because I think we look at people. I'm think Elon Musk is coming to my mind right now as someone that there's lots of big controversial figure, and many people will say, "Oh, he's a genius," and I've no doubt he's a wonderful, very good entrepreneur and very intelligent. But again, putting that label on him, people assume, or people think, "Oh, well, that means he can do anything." Right? If he becomes, if Trump becomes president and Musk takes this special role in government, of course he'll do well at it, because he's a genius, right? He's just got this magic touch which makes him, good at anything. And I think that is quite that is a dangerous way of thinking about things.
Yes, and also you're allowed to behave how you like. You can be, if you're a genius, you're allowed to be terribly rude, or you don't have to obey the rules that the rest of society does. You're somehow exonerated.
In fact, you're probably, in some sense, you're kind of encouraged to do that, in that it makes better stories, right?
Someone like, Einstein would be a good example of that, or else Isaac Newton. I mean, their stories of their eccentricity abound, but whether or not that was their normal behaviour, or whether it was something that was invented and then exaggerated, is impossible to know.
I think one thing I do think that the idea of genius does do quite well, however, is it gives this sense of if instead of us thinking of a genius, if one thinks of moments of of genius, or there is this idea of genius of kind of like inspiration, I suppose.
Yes.
And that's one thing that all of those stories you mentioned have in common,
Yes.
the bath and the apple and so forth. And while I'm sure they're apocryphal to an extent, I'm also sure that they do capture something of the process. Another story I really like actually is just Einstein shaving in the mirror every day and just thinking each day as he looked at himself, oh, what's going on like with these particles of light. It's quite it's another kind of moment of, I don't know, stillness, inspiration. I don't know, how do you feel? Yes, do you think there is this kind of creative spark or that?
Well, you have to have a huge amount of knowledge in order to make that leap. Right. I think also that sort of aha feeling is something that everybody has to a much lesser extent in ordinary life. I mean, I don't know if you're doing a crossword puzzle or I don't know if you're working on a maths problem. It's funny, you can work on something for ages and suddenly it all comes together and you work it out. But I think the myth of genius disguises the amount of hard work that's needed. So going back to Newton, he supposedly had the flash of inspiration when he was at Woolsthorpe during the plague in the 1660s, was supposedly when he watched the apple fall from the tree. But his great book on gravity, the Principia, didn't come out until 1687 because it took him 20 odd years to do the experiments, to work out the mathematics, to consolidate it from that original kernel of an idea. So it's rather like Edison said that genius is 1% inspiration, 99% perspiration. And I think there's a lot of truth in that.
Yes, yeah. It's just the 1% makes the better story. And then the rest of the 99% is just
and people like stories, but then it becomes the whole of science becomes romanticized and mythologized. And I think one of the efforts that historians of science have been making during the last 20 or 30 years is to debunk all those stories, is to go behind them and just try to present some sort of reality. But of course, whatever you do as a historian, you've got all the facts in front of you and you can interpret them in different ways, and different people will always give different versions of what happened in the past. And that's what, for me, makes being a historian so exciting, is you can put your own imprint on the past and you can retell it. There's always room for a new story to emerge.
Yeah. On this idea of, I mean, one thing I actually quite like about the Einstein example, just to ponder on it a tiny bit more, is there's no instant, as far as I understand, where he has this idea of riding on a photon, but I like to picture him doing the same routine day after day, and just like allowing himself the space to think on this problem. And he has all the pieces there, everyone's done their Michelson and Morley have done their experiment, and there's all these kind of contradictions and problems flying around.
He apparently didn't know about the Michelson and Morley experiment.
Oh, right, really? He didn't?
When he devised the theory of relativity in 1905. So that's a very good example of one of the great myths. It makes such a good story that Michelson-Morley showed there wasn't ether drift, and Einstein proved it. But it didn't happen like that. It was independent.
Well, that actually makes it even more interesting in that, he was able to make so much. I mean, in some ways, the special theory of relativity is something that could have come so much earlier, because it actually so simple to derive from just a single principle.
So that's a wonderful example of contingency, as you just said yourself. It could have come much earlier. Perhaps, I mean, how many other laws or supposed laws of nature are there that were never elucidated at all, or are still waiting to be elucidated, that could have been stated at 100 years earlier?
Yeah.
I mean,
what's your point? I mean, perhaps
path.
Perhaps they were, right? Perhaps some of these things were captured, like the example of the washing one's hands, but they just didn't get picked up.
Yes, or else the other classic example of that, of course, is Mendel's experiment on split peas, which sat around in an obscure journal for about 40 or 50 years before it was discovered independently by 3 different people, and then, thanks to Patrick Bateson, became the foundation of modern genetics.
Yeah, yeah, yeah. It's really yeah. It's very hard to imagine how different the world could be, because science does seem so kind of ineluctable in that we get this thing, we get that
Yes.
thing. But
Yeah, and then if you think back, I mean, genetics is a good example. It's very easy to make a simple equation that you had Darwinian evolution and then you added in Mendelian genetics and you got the form of evolution that we have today. But it was absolutely not like that. There were all sorts of other experiments or sort of other avenues of research, mathematical ones as well as environmental ones. And it wasn't until the 1930s that a new synthesis was reached, and evolution is still contested territory. And yet, still, we celebrate, endlessly, we celebrate Charles Darwin as the man who went to the Galapagos Islands, saw the different shapes of beaks on the different islands, and hey presto, that was the theory of evolution. The real story is much more complicated, and I think probably much more interesting.
yeah, I guess it starts earlier and finishes later. And Curiosity starts with,
There's
his
still
relation.
lots of debates about the theory of evolution. Yeah.
Yeah, I've read recently the Hail Mary project by Andy Weir, who wrote the Martian, and one of the things I really loved about it was so without giving away too many spoilers. There's the kind of human protagonist meets an alien, and they've both travelled to a different star system. It's a novel,
Is it
yeah.
a novel? Yeah, okay.
And they both travelled to a different star system. And this alien, he was on a ship with a large crew, but all of his crew members have died, and he can't work out why. And this alien has like incredible. They're this kind of like, they use echolocation. They don't have eyes, so they don't see radiation, right? As we see, we never think of ourselves as seeing radiation. We just think, but we do see radiation. And so there's all sorts that they've never discovered radiation. And his crew members had died of radiation sickness. But they also hadn't discovered relativity. And so he'd also arrived at this planet much sooner than he'd expected. But they had managed to make really powerful rockets. They had really good material science, way beyond human material science. So they could kind of weld, and they just developed incredible kinds of strong materials that could withstand all sorts of heat, because they were also much, much hotter than we were. So I thought that was a really great example of how, I guess, the physical, our physical constraints may well have influenced the path that our science has taken. We gaze at the stars, right, and they have been an influence of wonder for so long, and then that led to really expensive instruments being built and really elaborate theories, and then more simple theories, more accurate theories. But certainly there's a lot of physical contingency, I think, in the history of science. But it's very hard to picture how. My feeling is there is as much historical contingency as well, but it's maybe harder to visualize how things could have developed very differently.
I think that's right, and I think now it's even more difficult to imagine because communications are so good around the world that more society is much more uniform than it's ever been in the past. But if you went back a few hundred years and you sailed from England to the Americas and then to China, for just as 3 random examples, you would have seen very different ways of living and different understandings that people held of the world about them. I mean, that's what the great anthropologists were looking at in the 19th century. But it's more difficult to see now because the globe has become completely uniform because of the spread of modern technology.
How uniform do you think science is, though? Because we see still a lot of cultural differences between countries at perhaps superficial levels of what food and dress one has, and we tend to, but we do tend to think of science. And again, it's very hard to talk about science because, as you mentioned, it's quite a lot of different enterprises. But nonetheless, we think of it being fairly homogeneous throughout the world in the way that it's practiced and pursued. Do you think that is, how accurate is that conception?
Well, it seems to me it's increasingly accurate because a lot of the major research, as far as I'm aware, a lot of the major research is basically run by America and farmed out to different places around the world. So my understanding is that there's far less individual difference than there used to be. So, for example, Japanese science 100 years ago was rather different from the kind of science that's being practiced here. And I suppose there's still local differences between different laboratories, different academic institutions within the Western world. But it seems to me that the world is a much more uniform place than it used to be. If you just look at Iran, I mean, Iran has got all the modern technology that's needed to send bombs over Israel and has got the potential for creating nuclear devastation as well. That's just one very, very immediately topical example of how technology is widespread and uniform throughout the world. There's no sense in which Iran's weapons are different from Israel's weapons.
Right. Whereas, some centuries ago, had a Chinese soldier and a
different levels of technological development. But
yeah, I think that's right. I think perhaps there are differences in the research emphasis placed by different countries, but in a sense, it doesn't matter too much because once the knowledge is generated, it's very quickly disseminated. I wonder also what you make of artificial intelligence, something which I see as being very driven by industry and not within the domain of academia so much anymore. Does that? What should we think of that?
I got very excited a few years ago. It was during lockdown, so I sort of developed lots of different projects, and I came across this woman called Guglielma Lister, who lived in the early 20th century, and she was a great specialist in slime molds, and I at that stage had never heard of slime molds, and they are now classified as a separate, I can't remember what the name is, but there's a group, like there's plants and animals and fungi, and slime molds are a group of comparable importance. And I got very excited in reading about an avenue of research in Japan, where in the early 20th century there was far more interest in organisms like that, and there was a lot of interest in fermentation because of the all the miso and the soy sauce and everything that they have in Japan and as a consequence, their chemical industries were developing in a different direction from those in Europe. So this was in the early 20th century, and there's now the exciting thing about slime molds is that they seem to make decisions in a different way from the ones that we're used to. So if you've got a modern computer, digital computer, it's just a set of either or gates thrust together. So all decisions are on either or. The slime molds, what they have the ability to do is, well, the classic example is someone took a map of Japan, and they put a blob of slime mold over the map on Tokyo, and then at various towns around Tokyo there were bits of food were placed on the map. And what the slime mold did, instead of spreading out uniformly over the entire map, what the slime mold managed to do was very quickly establish a transport system to get from Tokyo to the individual stations. And the way they did that was by rather than constantly having either or decisions, they would send bits of slime mold up off to report on different possibilities, and if something didn't lead anywhere, then the slime mold would effectively cut off the whole of that avenue of research. So there's a sort of heuristic way of carrying out research in which you don't necessarily get the absolute best, most efficient way, but you arrive at a solution very quickly. It's what's called the traveling salesman problem of how it is if how can a traveling salesman minimize the amount that he has to travel if he's got to drop off lots of packages in lots of different places, and that this alternative way of thinking about problem solving has been applied to a different sort of computer, which was used, for example, to locate cosmic webs using the Hubble telescope. And it seems to me that's a very, very exciting, very interesting example of a totally different way of thinking that was initiated within Japan in the early 20th century, within a different intellectual and cultural environment from the one that prevailed in Europe. But I have no idea where that has got to at the moment. I became very excited and interested about it, but I have no idea if it's still continuing.
Yeah. I think, well, firstly, I think it's a really good example of actually where just, again, some fortuitous phenomena in nature that's quite apparent when you look carefully can lead to a completely new avenue of research which hadn't struck people. On the other hand, I think there is a similar within quantum computing. There are two kinds of main quantum directions within quantum computing. I would say one is just qubits and computers which seem loosely related to classical computers, but each bit can be in many states at once. And then you have to develop very different kinds of algorithms to work with it. So it's very different to normal programming. It's more like figuring out how you combine patterns of waves to merge, in a sense, and give you a solution to some very complicated problem, which depends on what's happening when all the waves are not merging. But the other form of quantum computer, I think, is an adiabatic quantum computer, where you try to, very similar to the example of transport systems in Japan, you have some problem which has got like kind of, you could think of as a kind of geometrical problem, like the traveling salesman one, and you essentially want the computer to settle into, to show you what is the most efficient way of connecting all these pieces, and you set it up so that the lowest energy state will fulfill that. So it's quite similar. It's very similar in what the slime mold does, because the slime mold is trying to, I suppose, get the most food for the least effort. And so there is a sense in which it's also optimizing for energy. But so I think I'd love to know if the adiabatic quantum computing was inspired by slime molds. I think it's probably just a distinct, I think there are two things that operate under the same principle but have been probably discovered distinctly. But yeah, it may well be easier to work with slime molds than to work with quantum computers to develop that kind of
I was just introducing it as a very interesting example of how to think differently, and how, because it was fostered by a rather different structure of academic institutions in Japan at the time in the early 20th century, because of this emphasis on food technology. So, so everything was rather like how we were discussing earlier about how science is not ordained to proceed in a particular direction, but there's all sorts of contingencies, which means that science will develop on a much more sort of branching sort of model, leaving whole avenues unexplored that might potentially have been extremely valuable. I mean, it's a sort of what might have happened version of history, and we're never going to know.
Yeah. So it's both an example of an intriguing individual technology and also kind of a metaphor for for science itself, right?
Yeah,
Which
that
avenues does the
branching
slime explore?
method,
Yeah,
yes.
yeah,
Yeah, which was the
yeah,
idea, I guess, that Kuhn introduced with his idea of revolutions and paradigms.
yeah. One thing that does strike me about Kuhn is that yes, the paradigms get overturned, but in a certain sense, the methodology of science at another level doesn't.
Oh yeah,
Right? He doesn't.
I'm not a great Kuhn fan. I really don't believe in revolution. So I don't believe, for example, in the scientific revolution.
Yeah, yeah,
That seems to have been pretty much discredited, thank goodness. Although again, it's a myth that prevails, and people still talk about the scientific revolution. And it seems to me a very unhelpful way of thinking about what happened in the past. Change is much more gradual, and it happens in different directions, in different places, and things always have precedents, and there aren't sort of neat edges around it. And the scientific revolution, of course, was meant to have happened over 200 years. So it's hardly a revolution if it takes 200 years to happen.
yeah, yeah, yeah. I mean, I think it's probably comes back to this question of storytelling, and it's much easier to
Yeah,
tell a
absolutely.
story about a revolution than
Oh,
to say,
it's a lovely story because it totally vindicates modern science, because it's a modern science was born in the 17th century, 17th century, and it sort of set us off on the path to truth. It's a wonderful story for validating the whole of Western enterprise, but I don't agree with it.
yeah, yeah. I think that's um, always told with hindsight as well. Obviously, although I do feel like actually there's a lot of talk now about we are within a revolution of one sort or another, but it's never
Yeah,
really, yeah,
and I mean, it's like this whole battle of whole vocabulary of battle that's used. You know, scientists are fighting against nature.
mm,
We're making breakthroughs. I mean, it's sort of trying to make a story out of what's happening factually, and also to validate. It's always about winners and losers, and it's rather sad in a way that we always have to tell everything in those simplistic terms. It'd be nice to tell a story of cooperation and collaboration, for example, instead. It's much
yeah.
rarer to hear that.
Well, coming up to the Nobel Prize, I mean, the prize for the LIGO experiments did go to an enormous number of people. Do you think that that's a indicative of the way that science has changed, or maybe just indicative of the way that we're recognizing the collaborative nature of science, which has always been there?
I think that they've always, yeah, it's a change in the way of telling it. I think they've always been collaborators. I think there's very few occasions where it's the single man who's, or
Mm.
well, occasionally woman, but the single man usually who's on their own changed the whole of the course of science. Of course, it's collaborative, although people, well, perhaps cumulative would be a better word than collaborative. It's not necessarily people all working together, but results build up one upon the other upon the other. And if you look at any supposed revolution, there's always precedents and antecedents that you can trace if you look hard enough.
Yeah. Do you have any advice for people who are, I don't know, thinking of going into science or the history of science?
Well, they're two very different
Yes, they're
projects.
two very different things. But you did. I mean, you studied physics initially,
I studied
so
physics, and I think it was a great mistake. I've never done any physics since I left university. And looking back, I think what happened is that I was a very high powered, a very good direct grant school, which unfortunately they don't have any longer, where you passed 11 plus, you got a scholarship and had a completely free education. Marvellous organisation. But anyway, we don't have direct grant schools now. But I was at an all girls school, very high powered. I was very good at physics and maths and chemistry. And I think everybody was so pleased to have a girl that was good at it that I was steered into studying science at university, studying physics at university, without anybody, including me, stopping to think, was that what I really wanted to do? And after I'd been
mm,
at Oxford a couple of years, I decided it definitely wasn't, especially all those hours and hours in laboratories looking down telescopes and things were absolutely terrible. And I knew I didn't want to do physics, but there was just no option. So I gritted my teeth, got on with it and graduated. And I've always sort of thought of that as an example. There's a model which I really dislike of the leaky pipeline to explain why it is that there's relatively few women at the top levels of science. And one of the metaphors that's often used is to say we've got to stop up the gaps in the leaky pipeline. Why is it? What are the obstacles that are preventing women going any further? And the implicit assumption of that is that science, physics, a career to become the director of a laboratory, for example, is the highest possible goal to attain. And so women are leaking out along the route to that because they're incapable of keeping up the pace. And it seems to me sort of quite insulting to women, but partly because it suggests that getting a top job in science is the most desirable position there is. But also, usually the way it's framed is to imply that the women, for some reason, aren't good enough. They can't keep up. They fail to match what their male peers are doing. But I'm an example of somebody who got a very good degree result. I didn't want to go on doing physics. It was a positive decision. I went off and I did all sorts of other things, and I've never regretted it. And it was a bit like I was saying about Rosalind Franklin earlier. There's always the easy assumption of making women victims rather than assuming that they're engineers of their own destiny.
I think it's also, as it suggests, it's also insulting to other subjects in a sense, in that
Yes.
Why should it be that we're so preoccupied with the lack of women in one regime when, I don't know, within pharmaceutical science or medicine or even teaching, there's areas where there's very good representation of women, and I'm sure many of them come
it's
from.
much better than it was. But there's also this assumption that science is the most supremely difficult subject. I mean, in a place like Cambridge, where there's a lot of very, very intellectual people around, several other fellows have said to me on occasions over the last 20 years since I've been at Cambridge, "Oh, good heavens, I didn't realise you did physics, you read physics. You must be terribly clever." And the assumption of that is that you have to be somehow more clever to read physics than to study any other subject of study. And I think that's an unfortunate legacy, that physics and maths and science more generally are held to be far more difficult than the art subjects. They're different. They're not more difficult.
Yeah. I think it probably does relate to this idea of genius. Again, like for whatever reason, we talk about artistic genius, we talk about scientific genius. We're less inclined to talk about someone who's a teaching genius or I don't know, even a surgical genius, right? And I'm not sure. Yeah, I'm not sure why that is. Maybe it's the particular kind of stories of these moments of discovery which attach to certain fields.
Well, teaching is always looked down on. Teaching is the profession that women often were channeled into, because if you're not good enough to actually do it, well, then you are good enough to teach it, because that's a secondary consideration. I mean, that's the classic way that teaching is represented. It's not what my own opinion is. I mean, I think you're right. You should be able to be a genius at teaching, and some teachers are certainly much better than others.
Yeah, I mean, if we're gonna have the concept and use it, we should permit ourselves to use it across all fields of human endeavor, right? Which, why not?
Well, the idea when the idea of a genius in a particular subject developed in this country anyway, it was mainly with the concept of romantic genius in the 18th century. And so Immanuel Kant, the philosopher, said Isaac Newton is an excellent example of someone who's not a genius. Because a genius has a flash of inspiration and they don't know how they've reached their results. So the prime example of a genius for Kant was Goethe, who was Kant told he was a literary romantic genius, whereas for Kant, Isaac Newton could not be a genius because he could explain logically every step of his argument along the way. So I think that's an excellent example of how the concept of genius has changed. Because he specifically said that Newton is an example of someone who's not a genius.
Yeah, that's interesting. Yeah, it's he was too rational, I guess, in Goethe's eyes at least, to be a genius. And
Yes,
yet,
and
in some
to
ways,
be a genius, you need the flash of inspiration, according to Kant.
yeah. Well, Kant, sorry, yes, and probably although one would now say, well, maybe Newton didn't know exactly in the moment where it came from, but he was certainly drawing together on. He had all the
Well, that's
materials
the,
before him. Yeah,
I mean, that's the apple tree story. The apple tree story is a romantic story of genius because he
mm,
suddenly had a flash of insight as though he had been illuminated by God, that he suddenly, all sorts of things fell together and he got the basic kernel. He said, why is it that an apple should fall down to the earth and not go up into the sky? Perhaps there's a power of universal gravity so that the moon is drawn to the earth or the earth is drawn to the sun, just like an apple is drawn down to the earth. So that was the insight that he allegedly had.
yeah, yeah. Or maybe it was just some good PR on Newton's
Well, he
side.
originated the story. It wasn't the story didn't become famous until the 19th century, and Newton originated it shortly before he died, just a few years before he died, and he told the story to 4 different people. So it's difficult to tell whether he completely made it up or whether he just didn't tell anybody
Yeah.
until he was in his 80s, and nobody can know. But it does originate with him.
Again, I'm sure there's a kernel of truth to it, but he was someone who sent lots and lots of portraits and busts of himself all over
He
the
did.
place.
He did, and
So
also once if you've established yourself or as an eccentric genius, then those are the stories you remember. I mean, you remember or you choose to tell the story of, I don't know, when Newton forgot to eat his lunch because he was so busy doing the problem. You don't tell the story about how 364 days out of the year Isaac Newton chomped his way through meat and 2 veg. I mean, that's a very boring sort of story. The only one you tell is the day that he forgot.
brilliant. This has been a really great and wide ranging conversation. Do you have any final comments, or perhaps you could I don't know if you mentioned that you're working on a new book or thinking about a new book
Well,
to
so
write.
what the book, I'm thinking about doing it, but it's a very early stages. There's a woman I mentioned earlier in our conversation, Hertha Ayrton, who was the first woman to read her paper at the Royal Society. I think she's an extremely interesting woman, and I'd like to write about her, not so much writing about the discoveries that she made, which were very important, but instead of prioritizing her science and focus more on the sort of life that she was forced to lead, or that she did lead, and bringing in comparisons with Marie Curie. So Hertha Ayrton's interesting, I think, not just because she was the first woman to read her paper at the Royal Society, but also because she was the first Jewish woman to study at Oxford. And I think it's quite interesting to see her in the context of the definite anti-Semitism that existed at the time, both at Cambridge and elsewhere. I think it's also interesting to think of her in terms of the way that she looked after other people, the way that she handled her domestic responsibilities, as well as her scientific research. And the more I sort of keep thinking about her and about Marie Curie, they were facing very, very similar problems about being marginalized. The way they met, they were at a lecture at the Royal Institution in 1903, and it was when Marie Curie had just carried out the experiments and had triumphantly emerged from sieving all the tons of pitchblende to arrive with a tube of radium chloride that glowed in the dark. But because they were both women and they both made their own independent discoveries, neither of them were allowed to appear on the platform. Both of them had to sit in the auditorium. And the person who described Marie Curie's experiments on radium was Pierre Curie, whereas in fact it was Marie Curie's own research project. Pierre was effectively her sort of collaborator, her assistant. And that's a sort of aspect of Marie Curie that one doesn't think about so much because she's become such a heroine in the
Yeah.
history of science. But actually, she was facing exactly the same problems as this far less distinguished person, Hertha Ayrton. And she just, Marie Curie just happened to be working, she had the good luck to pick up a marginal research project. When she started on it, no one was really terribly interested in the results of Becquerel and Röntgen, and no one realized that it was going to be the most exciting field of the early 20th century, or late 19th, early 20th century. She just had the luck to pick on a topic that no one else was researching, which left her free as an unknown woman to investigate it. And it happened, of course, she carried out wonderful experiments, and she was very original in her thought processes, but it was also slightly a matter of luck that she landed in this major field. Miss Hertha Ayrton also made lots of original discoveries. It's just in an area that nobody was particularly interested in.
Yeah. Another
But I
example
haven't quite worked out how to tell this story. That's just what I'd like to do. So I'd like to write a sort of double biography, sort of talking about their friendship, but not talking sort of the biography of a scientist with all the science left out, paradoxically.
Interesting. Yeah. Well, I think, I mean, as you say, yeah, the lives of the scientists are just as important in, or, you know, determining the route that the science takes. So
yeah, I mean, I think it's also interesting that there's only one woman in this country who's won a Nobel Prize for science, and that's Dorothy Hodgkin. And she won the Nobel Prize, I can't remember, I think it was in the 60s, for her work looking at molecules of insulin, penicillin. And she's an incredibly important woman. And very, very few people have heard of her. And I think she seems to have been an extraordinarily nice woman. She had 4 children, and she was married with 4 children, and she had terrible, crippling arthritis in her hands. But despite all her domestic responsibilities, despite this physical ailment that was making her research life very difficult, she seems to be extremely nice and equable, and there aren't, as far as I'm aware, there aren't any great mythical stories about her, and she remains uncelebrated, and I think that's very, very unfortunate. I mean, she is one of Great Britain's greatest female scientists, and everybody should know about her, and I think it's surprising that very few people do.
Well, it sounds like there might be another book on the horizon.
Yeah,
as well.
No, there is a very good biography of Dorothy Hodgkin already. I wouldn't presume to write one, but
okay.
It does annoy me and surprise me as well that most people have heard of Rosalind Franklin. I did a thing at one of the late events at the Science Museum once, and we sent a little questionnaire around the crowd and asked them to name 10 women scientists. And everyone managed Marie Curie. A lot of people, about half the people, managed Rosalind Franklin, and after that, most people drew a blank. They couldn't name any other female scientists. So, I mean, it's extraordinary that they couldn't even name Dorothy Hodgkin when she won a Nobel Prize.
I think I'd probably be remiss not to mention Emmy Noether, since we've talked about Einstein and so forth, because, you know, again, this idea that Einstein was a mathematical genius, well, he was very good at maths, but it was Noether who he turned to when he got stuck.
Absolutely, yeah.
Yeah.
And there's also, in terms of computing, there's a woman called Grace Hopper, who was in the American Navy, who was incredibly important in the invention of computers. In the development of computers, she invented COBOL, which is the commercial programming language, and she also introduced the term to debug a program, and originated from when moths were literally flying into the computer and fusing all the valves. She invented that term. So she's an incredibly influential woman in the early history of computers, and nobody ever talks about her. There's just a romanticized, absolutely mythical story about Ada Lovelace, who had nothing to do with the development of computers whatsoever. And the woman who was in the middle of computing history gets completely left out.
Yeah. Well, yeah. Thank you so much for highlighting all of these lesser known histories and reminding us just how much luck there is in what seems like the inevitable march of science, and
Yeah.
indeed just I don't know just how diverse that enterprise is. Thank you so much.
Well, thank you very much for inviting me to be on the show. I've enjoyed our conversation, so thank you.